Exercise 1.1. Is 0 a rational number? Can you write it in the form p by q, where p and q are integers and q does not equals to 0? For this, directly I will say yes. 0 can be expressed in the form of is equal to 0 is equal to 0 by 1, 0 by 2, 0 by 3, which is all equal to 0. These are all equal to 0, and you can also write 0 by minus 1, 0 by anything, 0 by anything, that is minus 150. Likewise, it's all equal to 0. So yes, where q is not equal to 0, where q does not equals to 0, but definitely sure that p is equal to, in all the cases p will be equal to 0, but q is not equal to 0 here. Second problem, find 6 rational numbers between 3 and 4. We want 6 rational numbers between 3 and 4. So what we will do means, we will take 3 and 4. As we want 6 rational numbers, we will add for 6 1, which is equals to 7. So we will multiply and divide by 7 both the numbers. So as we multiply and divide by 7, the value of 3 doesn't changes here, and here also the value of 4 doesn't changes, as 7 cancels. Yes, what happens here? 7 3s are 21 by 7, whereas here 28 by 7. Let us write all the numbers between 21 by 7 and 28 by 7. So what happens here? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7 are the 6 rational numbers between 3 and 4. 3. Third problem, find 5 rational numbers between 3 by 5 and 4 by 5. As in the previous problem, we want here 6 rational numbers, but here 5. So let us add 5. For 5, let me add 1. 5 plus 1 is 6. So I will take 3 by 5 and here 4 by 5. And I will be multiplying with 6. As I multiplied by 7 by 7, here 6 by 6. As I need 5, I will add 1, 6 by 6. Here 2, I will multiply with 6 by 6. What will be the answer here is 6 3s are 18 by 5 6 are 30. What happens here? 4 6 are 24 by 30. So 18 by 30 and 24 by 30. So next number is, after 18, it will be 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30 are the 5 rational numbers between 3 by 5 and 4 by 5. Here this problem is completed. Fourth one, state whether the following statements are true or false. Give reason for your answer. Every natural number is a whole number. It's true. True. Why means all the natural numbers, yes, all the natural numbers are there in whole number. In the set of whole numbers, there is only 0 is not there. 0 is there, which is not there in natural numbers. The extra number what is there in whole numbers is 0, which is not there in the natural numbers. So let us move on to the next one. Every integer is a whole number. False. The reverse of this statement is true. Every whole number is an integer. Every whole number you can understand by ear. Every natural number is a whole number. Every whole number is an integer. Every integer along with whole numbers and natural numbers is a rational number, and the set of rational numbers along with irrational numbers together forms real numbers. You should understand here properly. So here every whole number is a integer, but every integer is not a whole number. Y means -2, -3, that is the negative numbers, that is the negative numbers are not whole numbers. Are not whole numbers. Third one, every rational number is a whole number. Every rational number is a whole number. No, false. 1/2, 3/4, etc. are rational numbers. But not whole numbers. Therefore, false. Some examples from textbook. Fourth one, true or false? Every whole number is a natural number. Every whole number is a natural number. No. False. The direct answer is 0 is a whole number. But not a natural number. Next one is every integer is a rational number. You see here, integer, and here inside a rational number there is integers. So z is an integers and q is a rational number. So you can understand it by seeing this picture. So it's true because every integer can be expressed in the form of p by q, where q does not equals to 0. You may say -1. For example, let me give -1, which can be expressed in the form of -1/1. And the next example, let it be -2, which can be expressed as -2/1. Likewise, all the integers can be expressed in the form of rational numbers. Every rational number is an integer. Every rational number is an integer. This is false. But every integer is a rational number. The reverse is true, but here false. 3/4 is a rational number, but not a integer. Find 5 rational numbers between 1 and 2. So we need 5. So we will add 1 for that one. That is 5 plus 1 is 6. So 1 here 2. Let me multiply it with 6 and divide it by 6. Here 2 with 6 and divided by 6. 6 ones are 6 by 6. Whereas here 6 twos are 12 by 6. So the numbers next to this one is 6, 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6 are the 5 rational numbers between 1 and 2. From this we can conclude. Likewise we can get 5, 6. Likewise also 5, 6. As many number of rational numbers we need, that many number of rational numbers can be generated. So we can conclude that there are infinitely many rational numbers between any two given rational numbers. That has to be noted. Any two, 1 and 2, here for example in between 1 and 2 there are infinitely many irrational numbers between 1 and 2. Not necessarily 1 and 2, 3, 4, 101 and 102. In between 101 and 102 too, there are infinitely many rational numbers.